Hey, welcome. Ever feel like you need a translator every time you read an article about AI? Well, you're in the right place. Today, we're going to build a really simple, clear map of generative AI so you can understand what's actually happening under the hood. Let's dive in. Right? AI, ML, LLMs, it feels like you're drowning in this alphabet soup of tech jargon. But listen, you are definitely not alone. It seems super complex, but we're about to make it really simple. By the end of this, you're going to have a crystal clear picture of how it all fits together.
Okay, so the best way to get your head around all these terms is to think of them like a family tree. We're going to start at the very top with the great-grandparent of the whole field, and then we're going to zoom in generation by generation to see how each new idea built on the last one.
So at the very top of the tree, you have artificial intelligence, or AI. This is the big, overarching dream that started it all. It's the grand ambition of making machines that can think and reason and solve problems, basically to create something with human-like intelligence. Now, for decades, the way people tried to create AI was by writing millions and millions of lines of rules for every possible thing that could happen. As you can imagine, it was brittle. It didn't really work. A much more powerful way was needed, one that was based on learning, not just rules.
And that approach is machine learning. And this completely changed the game. Instead of programming a machine with super specific instructions, you just give it a ton of data and let it learn the patterns all by itself. It's all about learning from experience, not just following a rulebook.
But to handle all the messiness of the real world, like understanding pictures or human speech, we needed something even more sophisticated. So researchers looked for inspiration from the most powerful learning machine out there, the human brain. And this is where deep learning comes in. It uses something called neural networks that have many, many layers, which is why they call it deep. You can think of it like a detective team. The first layer spots simple clues, like lines and colors. The next layer puts those together into shapes, and the layers after that start recognizing complex things like faces or cars. It's this layered approach that lets it find incredibly subtle patterns in data.
So what happens when you take this super powerful deep learning technology and you pair it with internet-scale data and just a massive amount of computing power? Well, you get a totally new kind of model, one that can act as a base, a foundation for almost everything else.
These are foundation models. The big deal here is just the sheer scale. We are talking about training a single, enormous model on a huge piece of the internet. And the result isn't a model that's an expert in just one thing, it's a generalist. It has a broad understanding of concepts, of language, of logic, and it can then be adapted to do thousands of different jobs.
And this brings us right to the term that you've definitely heard a million times. It's what happens when you take one of these giant general-purpose models and you fine-tune it to be an expert in one very specific and very human skill: language. And that, of course, is the large language model, or LLM, the engine that powers tools like ChatGPT. So now you can see the whole family tree, right? An LLM is a type of foundation model, which is built using deep learning, which is a form of machine learning, which is a core part of the huge field of AI. See? It all connects.
So we've mapped out the family tree of all these models. But what's the one thing they all have in common? What's the one essential ingredient they all need to even function? Well, it's data. Without data, an AI model is like an engine with absolutely no fuel.
At its simplest, data is just information. But we're not just talking about numbers in a spreadsheet. It's the text of every book ever written, it's the pixels in every single photo on your phone, it's the sound waves of your favorite song. All of it is potential fuel for an AI model to learn from.
Now, AI models work with two main flavors of data. You've got your structured data, think neat, tidy spreadsheets and databases, and then you have unstructured data, which is, well, most of the data in the world. It's emails, videos, social media posts. It's messy, but the ability to make sense of this kind of data is what makes these modern models so incredibly powerful.
But here's the thing. It's not just about having a lot of data. It's about having the right data. Quality is everything. The data has to be accurate, relevant, and accessible. Because that old saying, garbage in, garbage out, is more true for AI than for anything else.
Okay, so we've got the concepts and we have the fuel. How do we actually put them together to build a working model? Well, it's a whole process, and we can think of it kind of like an assembly line with four main stages.
It all starts with data preparation. That's gathering and cleaning your data. It's not the glamorous part, but it's often 80% of the work. Next up is model training, where you feed that clean data to your algorithm and let it learn.
Then comes deployment, which just means you release your model out into the real world so people can use it. And finally, you have model management, because the world is always changing. You have to keep an eye on the model and update it to make sure it stays accurate and effective.
Now, that model training step we just mentioned isn't a one-size-fits-all kind of thing. Depending on the task and the data you have, machines can learn in 3 fundamentally different ways. First, there's supervised learning. Think of this like studying with flashcards that have the answers on the back. You show a model 1,000,000 pictures of cats that are all labeled cat. Then, you've got unsupervised learning. This is where you give the model a huge pile of data with no labels and just ask it to find interesting patterns on its own, like sorting a giant, mixed-up box of Legos by shape and color. And finally, there's reinforcement learning, which is all about learning through trial and error. Imagine an AI learning to play a video game by getting rewarded for good moves and penalized for bad ones until it just figures out a winning strategy. Now that we understand how all this incredible power is built, we have to talk about how to use it responsibly. And this is without a doubt the most important part of the entire AI conversation.
Responsible AI really boils down to 2 key ideas. First, you have secure AI, which is about defense, protecting your AI from being attacked or tampered with. Then you have ethical AI, which is about offense, making sure the AI models you build aren't causing any harm in the world. You absolutely have to have both.
And this isn't just some abstract conversation. To put these ideas into practice, organizations use established frameworks. These are essentially expert-designed checklists and best practices that help guide teams through managing the risks, making sure their models are built safely and securely from the ground up.
And that really is the key takeaway here. From the big picture of AI, all the way down through machine learning, foundation models, and the data that fuels them, understanding these fundamental building blocks isn't just for engineers anymore. It's the essential first step for anyone who wants to use this technology powerfully, effectively, and most importantly, responsibly. And that leaves us with one final thought. We've seen how these models are built and governed today, but as they get exponentially more powerful and woven into our daily lives, who should be the one to write the rules that guide their future? Should it be the technologists, the governments, all of us? It's definitely something to think about. Thanks for tuning in.